Okay, so the humming you might hear in the background is the fans off of a couple of 2600 routers. I've got a very simple setup here. I'm not going to go ahead and create a topology diagram for this. Basically, I've got R1 and R2. They're connected to a switch, and then off of that switch is this PC, which I will be running a Syslog server, which is actually from Kiwi, and you can see that here, and that will be at the IP address 10.100.1.100, and then these guys will also be on that subnet. So let's just, first things first, ping.10.100.1.2 from R1. So can I reach R2 from R1? Yes, I can. And can I reach my server? And I can. So we have IP connectivity, which is good. Alright, so the configuration, as we said, is pretty simple. We'll go into configuration mode, and I'm going to actually turn on logging buffered first. That's the local logging, so that we can see that the messages that we get here are the same as on the Syslog. And you can set a buffer size in bytes. I think it's 4096 bytes by default. Enter. So now let's get down to brass tacks and go ahead and hit login, and I'll show you the options here. Again, a lot of these are going to depend on your iOS version and your platform. We're on a 26. This is a 2610 or 2620 XM. Anywho, not a big deal. I think they're both running. No, they're not. They're not both running 12.4. Anyways, I am getting off base here. Some of these commands should be familiar from the theory section. So let's go ahead and do you remember what the only command that we really need to enter to enable remote syslogging is? Yes, it's logging host, and then we just need to provide an IP address or the host name. We don't have DNS running here, so we're going to provide the host name, the host IP address of 10.1.100, and lo and behold, we actually have logging configured. So now when I hit Control Z to break out of configuration mode, it should generate a syslog message, and we should see that on the console, which is, this is our logging console. And oh wow, look at that, we even got our logging has started to host 10.100.1.100. So if we go ahead and pull up our Kiwi syslog messages, look at that, we got the same two messages. They're in reverse order. We can sort them by time, going the other way. Oops, that's 8. There's a time. Gotta click the right field. Well, I thought I could sort them by that. Sorry. Anyways, I'm using this because I like Kiwi. It used to be, well, it still is free. There's different versions of it. There's a free version. There's also the Daemon Orb in the Windows world, the service. I'm running on a Windows box currently. I think this is a stripped down version. You can get a trial version with everything on it, I think for 30 days, and that'll give you some extra bells and whistles to play with. But anyways, this is good enough for our purposes today. So as we can see here, we get the messages in, and I'm going to go ahead and do one more thing here that is pretty important for your network, and that is I'm going to set the clock. Now, is it set clock or clock set? It's clock set. I always do that. And we will say it is 2057, and this is the 22nd of March 2010, and we will verify show clock, and this also generated a syslog message, so we should see another syslog message on our syslog, and we do. The reason you want to do this, and you're going to want to use NTP probably in your network, is you want to have these timestamps be accurate. You can see here that this was December 19th, and the year wasn't even specified, so here, that's a different lesson. Anyways, I just wanted to have these set up so that they were remotely similar, and you can see here, like I mentioned, that the syslog server itself does keep a timestamp as well. So this timestamp is going to be when the syslog message was generated on the Cisco router in this case, and this is going to be the time when it came into the syslog server. So there might be a slight difference between those times based on the clock that's on the server and the time that it takes for this packet to get from here to the syslog server. Okay, I'm going to pop over to R2, and we're going to do the same command. I'm going to do turn on logging buffered, and then I'm going to turn on logging 10.100.1.100. Let's see if it takes it. I didn't specify host. It did take it. I did notice that some versions of iOS will come back with an error message with this now. So we did discuss this in the slides that you can use either. And actually, when we jump back to R1, I'll show you that on the CLI. But we've got the same setup here. Let's go ahead and hit Control Z. This will generate a syslog message, and I'm going to set the clock here too. There we go. Okay, so So let's do our verification command, which is show logging. And you can see there's a few options here, but the only one you really want to look at is the full deal. And we do have this message in our log. We can see that our logging level is set for informational, which is 6, which is a default. We are logging to 10.100.1.100. Let's go ahead and ping this guy to make sure that we have reachability. I mean, this is one of the steps that you're going to obviously want to complete before you configure this, and we can ping it. So if I do a clear counter, that clears the counters on all the interfaces, but more importantly it will generate a syslog message. So let's go back to Kiwi. Okay, here we go. You can see here now we could tell that the host that this came from was the .2 host, so I know that this is R2. So this is how you can differentiate. Let's go ahead and play with some of the options. One of the first options I'm going to do is I'm going to configure loopback interface. So I'm back loopback 0 to, and then I'm going to set my logging source interface to loopback 0. So now when I hit Control Z, it should again generate a syslog message, and now when I see that syslog message on my syslog server, I can see that rather than using the host name of 10.100.1.2, which is the IP address of the fast Ethernet interface, which in this case is the only interface configured with an IP address on this device, so it's the only way that the packets can get out, it's going to use 2.2.2.2. That's the source interface, and that helps us to differentiate on the Syslog server which device the messages came from. So let's pop on over to R1 and do the same thing, and it's going to be logging source interface loopback 0, and this ought to be interesting because I have not specified loopback 0. I have not configured loopback 0 on this device. Let's see if it will take this command. It did. Interesting. Okay. That's very interesting because I did not configure loopback 0 yet. It's been created just by being referenced here. Let's do a show IP int brief. Actually, we have to do a do in front of that because we are in configuration mode. Well, look at that. It created loopback 0 for me. Of course, I don't have an IP address. And let's see what happened with our syslog messages that we created here. What going to use? We're still going to use the host name. You can see that we created a loopback 0 here, so that's kind of nice. It created the loopback 0 because it was referenced. I didn't expect that to happen, but it's still using the IP address of the interface that it's using to exit the router, which in this case there's only one exit. So let's go ahead and complete our configuration here with loopback 0. And now I should see. Now let's have fun and do a shut. No shut, and see what our messages say. There we go. And here we see them coming in. So now they have the host name of 1.1.1. So we can see that we've got messages coming from router 2 with this quad 2 and from router 1 with quad 1. I'm going to actually, here I can clear the display. Next up, let's go ahead and set the trap level on R1. So we'll logging, obviously. And here's our choices. And like I said, if you're taking a Cisco certification exam, I would commit these to memory. Day to day, you're probably not going to need to do that. By default, our trap level is going to be 7 for our local syslog destinations like the buffer, the console, but for the remote, it's going to be 6. So we want to change that to, let's say, 7. Hit enter. That's the highest that you can set, so that will have all syslog messages going to the syslog server. And let's do a show run, include trap. And you can see here that in the running configuration, even though we specified the numerical value of the severity level, it actually uses the keyword value in the running configuration. So you can use either for the configuration, but in the running configuration, it's going to show up as the keyword value. All right, so that's going to send all the syslog messages. Let's have a little fun here. Depends on how you define fun, but let's go ahead and set this for level 4. So now what it's going to do is it's going to only send syslog messages that are level 4 or below. Let's jump out of here. If I hit Control Z, it's going to create a syslog message, but if you see in the text of the message itself, it says sys 5. That means it's a level 5 syslog message. Because we set the limit at 4, so we're going to send anything 4 and below. If we do a show log, which will show you the, I mean, it's short for show logging. It's going to show you the local buffer at the end here. You can see that this shows up in our local buffer because we haven't filtered it here. That would be under the logging buffer command, which we are not going to play with. But if we jump out to our syslog server, we can see we haven't seen any new messages come because we're only sending 4s and below.